Hey everyone, and welcome back for another deep dive. You guys sent in some really fascinating articles about quantum computing and robotics, and well, honestly, this stuff is mind-blowing. It feels like we're stepping right into the future.
It really is an exciting time to be following these fields. The speed of these advancements is incredible.
Okay, so let's start with quantum computing. Now, I think a lot of people hear that term and their eyes kind of glaze over. It sounds complicated.
It can be, yeah.
So how do we unpack this? What exactly is quantum computing?
Well, you could think about it this way. Imagine a computer that uses quantum mechanics to operate. Basically the same rules that govern the universe at like the tiniest level, atoms and all that.
Okay.
And unlike our regular computers that use bits, which are either a 0 or a 1, quantum computers use these things called qubits.
Qubits, okay.
And here's the really wild part. A qubit can be a 0, a 1, or both at the same time.
Both at the same time? Wait, what?
Okay.
How is that even possible?
That's the magic of quantum mechanics. It's this concept called superposition, and it's one of the things that gives quantum computers so much power.
Okay, so it can be both 0 and 1 at the same time. But what does that actually mean in terms of, like, why is that so important?
Okay, imagine you're trying to find the best way out of a maze.
Right.
A normal computer would have to try each path one at a time until it stumbles on the exit.
Right.
But a quantum computer, because of superposition, can actually explore every path at the same time.
Whoa, okay, so they're like way faster.
Way faster.
Yeah.
It's not just about speed, though. It's a totally different way of processing information. That's why they have this incredible potential for solving problems that would take our regular computers, even the most powerful ones, millions of years.
Okay, so we're talking problems that would take millions of years for a regular computer. A quantum computer could do it in, like, what, a few seconds?
Potentially, yeah. It depends on the problem, but the speed up can be absolutely mind-blowing.
So it's not just like a slightly better computer, it's like a completely different beast altogether.
Exactly. It's a whole new paradigm.
Okay, so that's the theory. But what about right now? What are some of the practical applications of quantum computing today?
Well, one of the most promising areas is in drug discovery.
Drug discovery.
Yeah. You see, quantum computers can simulate molecules at the atomic level. So scientists can use them to study how different drugs might interact with the human body, without having to actually synthesize and test them in a lab.
So we're talking about like virtual drug testing.
Exactly. And because they can explore so many possibilities simultaneously, it could dramatically speed up the process of finding new and more effective treatments.
That's incredible. I mean, are we talking like cures for diseases that have stumped us for years?
It's definitely a possibility. I mean, the potential is huge. And here's another exciting development. Companies like IBM and Google, they're offering quantum computing services through the cloud now.
Oh, wow, through the cloud. So like anyone can access it?
Well, not just anyone, but researchers and businesses can start experimenting with this technology without having to build their own quantum computers, which are incredibly expensive.
It's becoming more accessible. That's great. I also read about another breakthrough, room temperature quantum computers. I mean, for a long time, those machines had to be kept super cold, right? Like near absolute zero.
Yeah, that was a big hurdle. It required these massive cooling systems, which made the whole thing even more complex and expensive. But now, with a room temperature operation, things are changing.
So this means the cost and complexity of using these things could go down significantly.
Exactly. It opens up a whole new world of possibilities.
Okay, so imagine quantum computers becoming more common, maybe even in everyday settings. I mean, what kind of impact could that have?
Well, think about the ripple effects across industries. I mean, imagine smartphones with quantum chips. They could become exponentially more powerful. Or what about medical devices with real-time diagnostics based on quantum computation?
It sounds like we're talking about a fundamental shift in how we interact with technology. But with all this amazing potential, I have to ask, are there any downsides? Like any concerns that we should be aware of?
Well, one of the biggest concerns is in cybersecurity.
Oh, cybersecurity.
Yeah, a lot of our current encryption methods, the ones that keep our online banking secure, our private communications safe, they're all based on mathematical problems that are really hard for regular computers to solve.
Right.
But a powerful enough quantum computer, well, it could potentially crack those codes.
So it could render all our current security measures useless.
It's a real threat that we need to prepare for.
So what can we do about it? Is there any way to protect ourselves from this quantum hacking apocalypse?
There is. Researchers are working on something called quantum-safe cryptography. Essentially, they're trying to develop new encryption methods that are resistant to quantum attacks.
So it's like a race against time, trying to stay one step ahead of the quantum hackers.
You could say that, yeah. And it's a good reminder that every technological advancement comes with its own set of challenges.
Right, so it's not all sunshine and roses.
Well, there are always trade-offs.
Yeah.
But it's crucial to be aware of these challenges and to work towards solutions as we continue pushing the boundaries of innovation.
It's like every solution creates a new set of problems that we need to solve, but that's part of the journey, right? Now, speaking of problems, there's another technology that's often portrayed as both a solution and a potential problem: robots. And it feels like we're on the verge of a robotic revolution. What do you think?
Well, we are seeing some pretty amazing advances in robotics, and a lot of it is driven by breakthroughs in artificial intelligence and sensor technology. Robots are becoming so much more sophisticated, you know? It's not just about clunky machines doing repetitive tasks anymore. They're learning, adapting, and even interacting with us humans in more meaningful ways.
Okay, I need some examples here. What are we talking about? What are some real-world applications of these advanced robots that are really blowing your mind?
Well, you've probably seen videos of Tesla's Optimus robot, right?
I have, yeah, the humanoid one.
Exactly. They're designed to handle a wide range of tasks, everything from working in warehouses and factories to maybe even helping with elder care someday.
I have to admit, seeing those videos of Optimus walking around manipulating objects, it's both fascinating and kind of creepy. Is that really the future we're headed towards? Robots doing all our jobs, A&D taking care of our grandparents.
It's a possibility, yeah. What's really driving this progress is the combination of artificial intelligence, or AI, and those advanced sensors I mentioned. These robots can now perceive their environment, make decisions in real time, and even learn from their experiences.
So they're not just following pre-programmed instructions anymore.
Right, they're becoming much more adaptable and versatile than traditional robots.
So are we essentially creating machines that can, like, think for themselves?
In a way, yes.
Yeah.
They can process information from their sensors, make judgments based on that information, even solve problems they haven't encountered before. And all of that thanks to advances in AI.
That's both incredible and a little terrifying. I mean, what are the implications of creating machines that are so intelligent and autonomous? What could possibly go wrong?
You're right to be asking those questions.
Yep.
There are definitely ethical and societal considerations that we need to address as these technologies keep evolving. We have to think about things like job displacement, safety protocols, and how to make sure these machines are used responsibly.
So it's not just about the technological advancements, it's about understanding the broader impact on society and making sure we're using these tools for good.
Exactly. We need to have some really honest conversations about the potential benefits and the risks. And we need to work together to create a future where technology serves humanity, not the other way around.
Well said. Okay, my head is already spinning with all of this, and we've only just scratched the surface. This is definitely a conversation we need to keep having. What happens when we take the power of quantum computing and combine it with these increasingly intelligent robots?
Now that is where things get really interesting.
I can't wait to dive into that. But I think this is a good place to pause for now. We've covered so much ground already, from the bizarre world of quantum mechanics to robots that can learn and adapt. I think we all need a moment to process.
It has been a fascinating discussion, that's for sure. And it really highlights the incredible speed of innovation in these fields.
Join us for part 2, where we'll explore the mind-blowing synergy between quantum computing and robotics. We'll delve into the potential, the challenges, and the ethical considerations of this powerful combination. It's going to be wild. Last time we were talking about how quantum computing could totally revolutionize things like drug discovery and cybersecurity, and then we got into robots and how they're going from like these simple machines to, you know, AI-powered partners, and I gotta say, I'm still processing all that. But the thing that really caught my attention was the idea of like merging these two powerful technologies.
Yeah, the synergy between quantum computing and robotics is like one of the most exciting areas of research today. I mean, imagine robots that can not only perform tasks, but can also learn and adapt like way faster than ever before, thanks to the power of quantum algorithms.
So we're not just talking about robots that can do things faster or more efficiently, but they're actually becoming smarter and more capable. Like, what would that look like?
Well, think about a robot working in a disaster zone, like a collapsed building after an earthquake. It needs to navigate like unstable debris, identify survivors, find the safest path to reach them. A quantum computer could analyze all that sensor data from the robot in real time, factoring in things like structural integrity, potential hazards, location of survivors, to guide that robot along the best possible route.
That's a powerful example. Instead of just relying on its programming, the robot is using quantum computing to make smart decisions on the fly in a really complex and dangerous situation.
Exactly. It's about moving beyond just automation and towards true autonomy, where robots can actually understand their environment, adapt to unexpected challenges, even learn from their experiences to get better over time.
Okay, so that makes sense for disaster response, search and rescue, maybe even space exploration. But what about AI? We were talking earlier about how AI is already making robots so much more capable.
Right, and this is where the convergence of quantum computing, robotics, and AI becomes really revolutionary. Quantum computers can actually speed up the training of machine learning models, which are like the brains behind AI. So imagine a robot that can not only perform surgery, but can also learn from every surgery. It does, constantly refining its technique and becoming more precise.
Wow, we're talking about creating robots that can learn super fast, becoming more skilled and knowledgeable with every task they perform.
Exactly, and it's not just about making individual robots smarter. Imagine a whole network of robots all sharing their experiences and learning from each other through a central quantum computer.
Whoa, the collective intelligence of that system could be off the charts. Okay, now we're getting into some serious sci-fi territory here. But it's also incredibly exciting to think about the potential benefits. So where else could this synergy have a major impact?
Well, one area that's ripe for disruption is transportation.
Yeah.
Think about self-driving cars and trucks. They rely heavily on AI and sensor data to navigate and make decisions in real time. Quantum computing could take this to a whole new level.
I'm imagining traffic flows being optimized in real time to prevent congestion and accidents, and maybe even delivery drones that can navigate complicated cityscapes with incredible precision.
Exactly, and beyond transportation, we could see quantum-powered robots transforming industries like manufacturing, agriculture, healthcare. Imagine robots that can perform really intricate assembly tasks or assist with complex surgeries, freeing up human surgeons to focus on the most critical parts of the procedure.
It sounds like we're on the cusp of a technological revolution that could totally change how we live and work. But I also have to ask about the downsides. Are there any risks or ethical things we need to be thinking about?
Of course, with any powerful technology, there are always potential downsides. One of the biggest concerns is job displacement. As robots become more capable and autonomous, they might be able to do jobs that are currently done by humans.
Yeah, that's a valid concern, and it's not just about jobs. We also need to think about these technologies being misused or even weaponized.
Absolutely. We need to be really thoughtful about the ethical implications of creating machines that are this intelligent and powerful, and make sure they are developed and used responsibly with safeguards in place to prevent harm.
So it's not just about the science and engineering, but also about having open conversations about the impact on society and making sure we're using these tools for good.
Exactly. The future of quantum computing and robotics is not set in stone. It's up to us to shape that future to make sure these technologies align with our values.
This has been a seriously thought-provoking conversation, and I think we've only just scratched the surface of this whole complex and rapidly evolving landscape.
It's a fascinating time to be following these developments. The pace of innovation is mind-blowing, and the possibilities seem almost endless.
Okay, but before we get too carried away with all the amazing potential, let's take a step back and consider some of the challenges that are still out there. So we've talked about this amazing potential of merging quantum computing and robotics, everything from revolutionizing healthcare to creating truly self-driving cars. But as with any new tech, there are going to be some roadblocks, right? What are some of the biggest challenges facing these fields right now?
Yeah, for sure. Well, on the quantum computing side, one of the biggest challenges is scalability. Building and maintaining these machines is super complex and expensive. We need to find ways to make them more stable, more efficient, and more cost-effective if we want to see them used more widely.
So it's not just about the initial discovery, it's about making the tech practical for everyday use. What about on a robotics side? Are there any challenges holding things back there?
One of the key challenges in robotics is developing AI systems that are really robust and reliable. I mean, we've made great strides in machine learning and computer vision, but AI still struggles with things like common sense reasoning and adapting to unexpected situations.
So a robot might be great at doing one specific task in a controlled environment, but if you throw in some unexpected variables, it could easily fall apart.
Exactly. We need to develop AI systems that can learn and adapt more like humans, be able to reason about the world, understand context, make decisions even when things are uncertain.
That makes sense, and I imagine that as we create robots that are more intelligent and autonomous, the ethical considerations become even more important.
Absolutely. We need to be having some serious conversations about things like, robot rights, accountability for their actions, and making sure that these machines are aligned with human values and goals.
It's like we're entering this whole new chapter in the relationship between humans and technology. We're not just using machines as tools anymore. We're creating machines that can think, learn, and potentially make decisions that could have a real impact on our lives.
It's a huge shift, and it requires us to think differently about ethics responsibility and what role technology should play in society.
So where do we go from here? What are the next steps in this journey toward a quantum robotic future?
I think we're going to see a lot more investment in both basic research and practical applications for quantum computing. We'll probably see some breakthroughs in things like quantum error correction and qubit stability, which will pave the way for more powerful and reliable machines. And for robotics, we can expect to see advances in AI sensor technology and material science, leading to robots that are more capable, more adaptable, and maybe even more human-like.
It sounds like there's a lot to be excited about and a lot to think about as we move into this uncharted territory.
Absolutely. The future of quantum computing and robotics is full of potential, but it's also full of unknowns. It's up to us to approach these technologies with both curiosity and caution, making sure they're used to benefit humanity and create a better future for everyone.
Well said today. We took a deep dive into two of the most transformative technologies out there, quantum computing and robotics, and we explored their potential to revolutionize industries, solve complex problems, and even change our understanding of what's possible.
It's been a really fascinating exploration, and I hope it's made our listeners curious and maybe even a little skeptical.
As these technologies keep evolving, it's super important to stay informed, think critically, and participate in these conversations that will shape how they develop and impact the world.
It's been great being here today.
And a huge thank you to all of you out there for joining us on this journey to the frontiers of technology. Keep exploring, keep questioning, and keep imagining the possibilities of a quantum robotic future. Until next time, keep diving deep.